We continue looking at relations, functions, and graphs. Now we will look at the function and what is meant by one-to-one relation, as well as repeat some of the terms that we have used in earlier video where we looked at relations. Now, what is a function? Well, according to Mathematics A Complete course by Raymond Tulsi, second edition, a function is defined as a relation in which each element in the domain is mapped onto one and only one element in the range. Each element in the domain is mapped onto one and only one element in the range. Now, let's look at an example. Suppose I have x is mapped onto 2x plus 4. Now that's one way of writing a mapping. Now, another way of writing a mapping is in this way of writing a function being mapped. F of x is equal to 2x plus 4. Now, this is somewhat similar to the form y is equal to 2x plus 4. But instead of saying y now, we just use f of x. The f of x could have been g of x, could have been h of x, or other letters of x. But f is a popular number for us to use. Now, let us put in some values for the domain. 1, 2, 5, 7, 15. Now, what would we have at the range? 2x plus 4 when x is 1. Remember, these are x and these are f of x. Domain, range. The range is f of x. When x is 1, 2 times 1 plus 4 is equal to 6. So we have 6 here. When x is 2, 2 times 2, remember x is 2, 2 times 2 plus 4 will give you 8. 4 plus 4 is 8. This is 4 plus 4. That's 8, right? Let me just put my x in a different letter here, in a different color here. So you can easily see the x that I'm calculating, right? When x is 5, then you have, when x is 5, then f of x is equal to 2 times 5. X is 5 plus 4, which will give you 10 plus 4, which is 14. So 5 will be mapped onto 14. So what we have so far, 1 is mapped to 6, 2 is mapped to 8, 5 is mapped onto 14. What about 7? Let's look at what happens when x is equal to 7. X equals 7. Then f of x is equal to 2 times 7, which is the x, plus 4. 2 times x plus 4, 2 times 7 plus 4, because x is now 7, which is 2 7s, 14 plus 4 will give you 18. So 7 is mapped onto 18. Remember, this was 15. Let me write it properly. Now, when x is equal to 15, x is 15, then f of x is equal to 2 times 15 plus 4. 2 times 15 is 30. 30 plus 4 is 34. So we have 34 here, and 15 is mapped onto 34. Now we see that each element in the domain is mapped onto one and only one element in the range. Now let us look at another example. Let's erase these first. We want another example. Suppose we have f of x is equal to x squared. We're going to square x this time. We can have some values of x we can have, let's say, 1, 2, 3, negative 3, negative 2, negative 1. These are values of x. And these will be values of x squared, which is f of x. So that's f of x. Now, let's see what will happen when x is 1. When x is equal to 1, f of x will become f of 1, because x is 1. And what you have is 1 squared is equal to 1 times 1, which is 1, because 1 multiplied by 1 is 1. So we have 1 in the range. Now, let's see what happens when x is 2. We have 2 for our x here. Now, instead of writing f of x again, we have f of 2. So what we have is 2 squared. And what we get, 2 squared is 4. So we have 4 over here. And just like how 1 was mapped onto 1 here, 2 is mapped onto 4. Now, when x is 3, x is 3 in this case. So f of 3, our x, f of 3 is equal to 3 squared. So we have our 3 squared. What is 3 squared? It's 9. So we have 9 in the range, and 3 is mapped onto 9. Nice, you see that? Now, what about when x is negative 3? F of negative 3 will be equal to, what is negative 3 squared? It's negative 3 times negative 3. Negative 3 multiplied by negative 3. And what you have is 9. Now at this point, some persons might try with a calculator and they type in negative and then 3 and square, and what they get is negative 9 on the calculator. The calculator is programmed to say negative 3 and then the 3 squared and it negatives that, because negative means the same as negative 1 multiplied by 3 squared. So that's what the calculator did. So you have to be careful when using a calculator. To get the correct answer for that, what you will do is open bracket, negative 3, close bracket, squared. That's on the calculator. Alright? Alright, continuing this, negative 3 by negative 3 gives you negative 9. Gives you positive 9. Alright. But why should I write 9 here? 9 is there already. If I write 9 here, it wouldn't be necessary. Right? We already have a 9. So we map negative 3 onto 9. Let us see what happens when x is negative 2. We have f of negative 2 is equal to negative 2 squared, which is negative 2 times negative 2. Alright? Negative 2 multiplied by negative 2, and that gives us positive 4. Negative 2 is mapped onto, sometimes you see these dots appearing. They appear by error because of the drawing tablet that I'm using. Now, I have negative 2 being mapped onto 4. But the thing is, 4 is there already. So I can map negative 2 onto 4. Now, what about negative 1? You will do the calculation for negative 1 now. And what you will find is that negative 1 is mapped onto 1. Because negative 1 square is 1. Now, what you have is each value in the domain is mapped to one and only one value in the range. So it is a function. It's still a one-to-one mapping. Alright? Now, as to whether it's a function, you can try and remember it like this. In a case where you have an election, you might have a small election. You're choosing someone, whether a class representative or someone to chair a committee or a club. You can have 5 persons there. Right? A, B, C, D. Alright, 4 persons there running for office. And the voters, 1, 2, 3, 4. Person 1 vote for A, person 2 vote for B, person 3 vote for C, person 4 vote for D. No problem. One person vote for one candidate. So it is a function and it operates like an election. Now in this case, you can have more than one person vote for the same candidate. One voted for one, and negative 1 also voted for one. No problem. Right? So it is a function, and it's like an election that's functioning properly. Now, in the next video, we'll look at a relation that is not a function, but just to introduce it here. if you have a case like this, 1, 2, 3, 4, A, B, C, D, one person 1 votes for A, this is 2, person 2 votes for B. Now you have person 2 votes for C2. That's a violation. That's fraud. You cannot vote for 2 candidates. Right? In a national general election, you have to dip your finger in the ink so that when you come back, if you try to come back, they will detect it. And if the officials detect that you voted already and you try to return to vote again, you go straight to jail. You have committed an election fraud. You cannot have a one-to-many vote. One person cannot vote for 2 candidates. That's illegal. Now in that case, that is not a function. Well, you can use that to remember what a function really is and the definition of a function. But we will look in another video at a relation that is not a function. So I will see you then.